Here I am going to talk about empirical rule. Empirical rule is also called 68, 95, and 99.7 rule. This rule gives the amount of data present within 1, 2, or 3 standard deviations from mean. So let me explain the graph here. So this point here is 1 standard deviations from mean. This point here is 2 standard deviations from mean, and this point here is 3 standard deviations from mean. So let's look at the other side. So it is also, so this point here is also 1 standard deviation from mean. So this is 2 standard deviation from mean, and this is also 3 standard deviations from mean. This tells us that 68% of all values fall within 1 standard deviations of mean, and this tells us that about 95% of all values fall within 2 standard deviations of mean, and this tells us that about 99.7% of all values fall within 3 standard deviations of mean. So let me explain the graph here. So if we look at the graph area from here to here, okay, so basically from this point to that point, okay, it is 68%. But just the area on one side is 68% divided by 2 on this side, and same thing on here, 68% divided by 2 on that side. So 68% divided by 2 is 34% on this side, and 68% divided by 2 over here is 34% on this side. So this area over here is this area, and this area over here is 95% minus 68%. Then just the area on this side is 95% minus 68% divided by 2. Okay, and same thing on here, just the area on this side is 95% minus 68% divided by 2, which is 13.5% on this side and 13.5% on that side. Now these two sides, this side and this side, is 99.7% minus 95%, but just the area on this side is 99.7% minus 95% divided by 2, okay, and same thing on here. So it is again 99.7% minus 95% divided by 2. So which is 2.35% on this side, okay, and same thing on here, it is 2.35% on this side. Now, so the area over here towards the tail on both sides is 100 minus 99.7%, and the area just one side, on one side is 100% minus 99.7% divided by 2, and same thing on here on the other side. So it is 100% minus 99.7% divided by 2, and just the area at one tail is 0.15%, and the area on the other tail is 0.15%. Now let's look at some examples for empirical rule. So suppose that the average height of Lilliputians is 6 inches with a standard deviation of 1 inch. Using the empirical rule, we need to find the percentage of Lilliputians with height from 4 inches to 8 inches. So on here, first put down the values along the horizontal axis with mean in the middle over here, and steps of standard deviations on both sides of mean. So that means our mean is 6 and our standard deviation is 1, which is which I got these numbers from here. Mean is 6 and the standard deviation is 1. So plugging in those numbers on here we get 6 plus 1, on here we get 6 plus 2 times 1, on here we get 6 plus 3 times 1. Okay? So on the other side we get 6 minus 1, and over here we get 6 minus 2 times 1, and on here we get 6 minus 3 times 1. So that becomes 6 plus 1 becomes 7. So this is 8 and this is 9. Okay. So on the other side, it is 5, 4, and 3. Now then look at the total percentage between 4 and 8. So between here to here. So it is also shown by the line, by this line over here. And if we look at here, it is also shown in percentage over here. So from the graph, we see that the percentage between 4 and 8 is 95%. Now let's look at other example. Okay. So on here, suppose that the average height of Lilliputians is 6 inches with a standard deviation of 1 inch. Using the empirical rule, we have to find the percentage of Lilliputians with height from 3 inches to 70 inches. So in order to answer this question, first we need to put down the values along the horizontal axis with mean in the middle, and steps of the standard deviations on both sides of mean. So which are these ones. So we know our mean is 6 and our standard deviation is 1. So the steps of standard deviations on both sides of mean are 6 plus 1, 6 plus 2 times 1, 6 plus 3 times 1 on that side, and 6 minus 1, 6 minus 2 times 1, and 6 minus 3 times 1 on this side. So that becomes 7, 8, 9 on this side, okay, and 5, 4, 3 on this side. Then look at the total percentage between 3 and 7, which is also shown in with the line here. So we are supposed to be looking from here to here. If we look at inside the graph, it is shown with the shaded areas, shaded region. So we are looking at that percentage. So from here to here. So from the graph, we see that the percentage between 3 and 7 is, so we know the area from here to here is 2.35%. So that's why we have 2.35%. And from here to here is 13.5%. Okay. And from here to here is 34%. And so again, from here to here is 34%. So when we add all these percentages or all these numbers, we get 83.85%.